Hello dear students, welcome to EPG Pathshala. I am Dr. DC Saxena, Professor and Head of the Department of Food Engineering and Technology at Sant Longowal Institute of Engineering and Technology, Longowal. I am here to present the paper Technology of Meat, Poultry, Fish and Seafood Products. In the present module, you will be knowing the technical aspects of sauces and communited meat products by my co-author Ms. Romi Jan.
Hello students, welcome to EPG Pathshala. I am Romi Jan from Sant Longowal Institute of Engineering and Technology. Today I am going to talk about Module 14 of paper number 8, Technology of Meat, Poultry, Fish and Seafood. In this module, we will be learning about sausage manufacturing and the techniques involved in their manufacture. We will also study the technology of communited meat products. Pork is the most widely consumed meat in the world, with the majority in the US consumed as processed products, including the ham, bacon and sausage. In the United States, 19.8% of pork is consumed as a sausage product, such as bratwurst, frankfurters, and fermented sausages. The process of preserving meats by stuffing salted, chopped meats flavored with spices into animal casings dates back thousands of years to the ancient Greeks and Romans and earlier. Several categories of sausage products are typically consumed in the US, each with specific production processes and storage requirements. These categories include fresh sausages such as fresh pork sausages, cooked sausages such as frankfurters, and dry sausages such as meat sticks. Fresh pork sausages are produced from selected cuts of fresh and sometimes frozen pork, pork trimmings, and water along with seasonings. The contents of this module that I will go through includes the following: sausage and the processing technologies, which includes the production process and production requirements for different categories of sausages. In the United States, expansion in the meat packing industry during the Civil War, along with development of refrigeration for use in railroad cars and slaughtering facilities, provided an incentive for meat processors to create sausage products that could utilize cheaper, perishable cuts of meat along with scrap trimmings and offal products. In addition, persons from various nationalities and ethnic groups immigrated to the US, bringing with them traditional recipes and manufacturing skills for creating a wide range of sausage types. The word sausage is derived from the Latin word salsus, which means salted or preserved by salting. Sausages and sausage products have since evolved into a wide variety of flavors, textures, and shapes resulting from varieties in ingredients and manufacturing processes. A sausage is a food usually made from ground meat with a skin around it. Typically, a sausage is formed in a casing traditionally made from intestine, but sometimes synthetic. Some sausages are cooked during processing and the casing may be removed after. In Korea, emulsified sausages such as frankfurter and bologna may contain up to 35% fat with lower than 75% moisture in the final products, as regulated by the Korean Food Code in 1997. Bologna, which contains 10% fat, requires 24.3% added water to approximate the sensory firmness of bologna with 30% fat and 10% added water. However, too much reduction of fat down to 5 to 10% in comminuted sausages may result to darker color, variation in textural properties, and decreased juiciness and cooking yield. The manufacture can take place with basic meat processing tools and machinery, which includes cutting board, knife, grinder, funnel or manual stuffer. Meat and Poultry News 2000 published a survey indicating that 82% of consumers said a full English breakfast would not be complete without a sausage. The 1997 estimated total retail volume of United Kingdom pork sausages and beef sausages was 1,97,000 tons. Let's now discuss about sausage. Sausage manufacture is a simple process of allowing meat to undergo series of control, structural and chemical chains. These are basic to all cultures, but the chains rely on varied methods of preservation, preparation and spicing to achieve desired distinctive characteristics. Fresh meat and fat are mixed with salt and spices and stuffed into natural casings derived from small intestines of the slaughtered animals. These sausages do not undergo heat treatment at processor level but are roasted, fried, boiled or otherwise heat treated before consumption. Before consumption upon demand by consumers or by consumers themselves. Higher quality fresh sausages are primarily composed of lean meat and fat. On the other hand, chemical or biochemical processes, which often go together with the technical processes, are also part of meat processing technology, such as salting and curing, utilization of spices and additives, smoking, fermentation, and drying. Flow diagram showing purely technical processes used by meat processing technologies include such as cutting, chopping, comminuting, mixing, tumbling, stuffing or filling of semi-fabricated meat mixes into casings, synthetic films, cans, etc. Pieces of soft edible animal tissues can be reduced in size by passing them through meat grinders. Some specially designed grinders can also cut frozen meat. Others are equipped with devices to separate hard tissues such as tendons and bone particles from the soft tissues, minced muscle meat particles. Bowl cutters are used to chop and mix fresh or frozen lean meat, fat, water in the form of ice, functional ingredients which includes salt, curing agents and additives, and extenders which includes fillers and or binders. The animal tissues to be emulsified must be premixed with all other raw materials, functional ingredients and seasonings and pre-cut using grinders. Thereafter, they are passed through emulsifiers to achieve very finely chopped or emulsified meat mix. Boneless frozen meat blocks can be cut in slices, cubes or flakes by frozen meat cutters or flakers. The frozen meat particles 2 to 10 cm can be directly chopped in bowl cutters without previous thawing, thus avoiding drip losses, bacterial growth and discoloration which would happen during thawing. For small operations, the manual cutting of frozen meat using cleavers or axes is also possible. Back fat is cut in cubes of 2 to 4 cm on specialized machines to facilitate the subsequent chopping in cutters or emulsifiers. In small-scale operations, this process can be done manually. Salt, sodium chloride, that's NaCl, adds to the taste of the final product. The content of salt in sausages, hams, corned beef and similar products is normally 1.5 to 3%. Solely, common salt is used if the cooked products shall have a greyish or greyish-brown color, as for example steaks, meatballs or white sausages. Besides adding to flavor and taste, salt also is an important functional ingredient in the meat industry which assists in the extraction of soluble muscle proteins. This property is used for water binding and texture formation in certain meat products. In order to achieve the desired red or pink color, meat or meat mixes are salted with common salt, that's NaCl, sodium chloride, which contains a small quantity of the curing agent sodium nitrite. Sodium nitrite has the ability to react with the red meat pigment to form the heat-stable red curing color. The preservative effect, which is microbial inhibition and extension of the shelf life of meat products by salt in its concentrations used for food, on average 1.5 to 3% of the salt, is low. Meat processors should not rely too much on this effect unless it's combined with other preservation methods such as reduction of moisture or heat treatment. Consumers associate the majority of processed meat products like hams, bacon and most sausages with an attractive pink or red color after heat treatment. However, experience shows that meat or meat mixes after kitchen-style cooking or frying turn brownish grey or grey. In order to achieve the desired red or pink color, meat or meat mixes are salted with common salt, NaCl, which contains a small quantity of the curing agent sodium nitrite. Sodium nitrite has the ability to react with the red meat pigment to form the heat-stable red curing color. Only very small amounts of the nitrite are needed for this purpose. Nitrite can be safely used in tiny concentrations for food preservation and coloring purposes. Traces of nitrite are not poisonous. In addition to the reddening effect, they have a number of additional beneficial impacts so that the meat industries widely depend on the substance. Levels of 150 mg per kg in the meat product, which is 0.01%, are normally sufficient. To reduce the risk of overdosing of nitrite salt, a safe approach is to make nitrite available only in a homogeneous mixture with common salt, generally in the proportion 0.5% of nitrite and the balance of sodium chloride 99.5%. This mixture is called nitrite curing salt. At a common dosage level of 1.5 to 3% added to the meat product, the desired salty flavor is achieved, and at the same time the small amount of nitrite needed for the curing reaction is also provided. Due to the sensory limits of salt addition, salt contents of 4% are normally not exceeded. The amounts of nitrite are kept low accordingly. Nitrite has a certain inhibitory effect on the growth of bacteria. This effect is particularly pronounced in canned meat products, which are usually stored without refrigeration, where small numbers of heat-resistant bacteria may have survived but their growth is inhibited by the presence of nitrite. In the presence of nitrite, fats are stabilized and runstability in meat products retarded, that is, an antioxidant effect. Curing is applied for most chopped meat mixtures or sausage mix for which a reddish color is desired. The curing agent nitrite is added in dry form as nitrite curing salt. The reaction of nitrite with the red meat pigment starts immediately. Due to homogeneous blending, the meat pigments have instant contact with the nitrite. High temperatures during processing, for example, reddening of raw cooked type sausage at 50 degrees centigrade or scalding and cooking of other products at 70 to 80 degrees centigrade accelerate the process. Another accelerating or catalytic effect is the addition of ascorbic acid, which slightly lowers the pH of the meat mixture. However, the dosage of ascorbic acid must be low, 0.05%, just to provide the slightly acidic conditions for the reduction of sodium nitrite to nitric oxide. A pronounced reduction of the pH would negatively affect the water binding capacity of the product, which is not desirable. Besides the curing of chopped meat mixtures, entire pieces of muscle meat can be cured. However, due to size, the curing substances can't instantly react with the meat pigments, as is the case in chopped meat mixes. Hence, various curing techniques are applied. The final products of curing entire meat pieces are either cured raw fermented products or cured cooked products. The curing system to be used depends on the nature of the final product, uncooked or cooked. There are two systems for curing entire meat pieces, dry curing and wet curing, which means pickling, and the type of the final product determines which system will be used. In dry curing, a curing mix is prepared containing salt and nitrite curing salt, together with spices and other additives. The pieces of meat are rubbed with this curing mix and packed in tanks. The curing mix gradually permeates into the meat, which can be a lengthy process ranging from several days to several weeks. The second method of curing meat pieces is wet curing, also called pickling, which involves the application of curing brine to the meat. For the manufacture of the brine, curing salt and spices and or additives, if required, or dissolved in water. The meat cuts are packed in tanks and brine is added until all pieces are completely covered. A temperature of +8 to +10 degrees centigrade for the curing room is recommended, as lower temperatures may retard curing. For equal penetration of the brine, the meat is cured for periods ranging from several days to 2 weeks, depending on the size of the cuts and curing conditions. After completion of the curing, ripening periods for the products follow for taste and flavor build-up. An alternative and quick way of wet curing is to accelerate the diffusion of the curing substances by pumping brine into the meat tissue, injection curing. For this purpose, brine injectors with perforated hollow needles are used. The injection of brine into the muscles can be done manually by using simple pumping devices. At the industrial level, semi-automatic multi-needle brine injectors are used, which achieve very even distribution of the curing ingredients and can reduce the curing period, equal distribution of the curing substances or resting period to less than 48 hours. In addition, most injection cured meat pieces, which are to be processed into cured cooked products such as cooked hams, etc., are submitted to a tumbling process. Tumbling further accelerates the brine penetration throughout the meat pieces and resting periods are not necessary. Smoke for treatment of meat products is produced from raw wood. Smoke is generated through the thermal destruction of the wood components including the lignin and the cellulose. The thermal destruction sets free more than 1000 desirable or undesirable firm, liquid or gaseous components of the wood. These useful components contribute to the development of the following desirable effects on processed meat products: meat preservation through aldehydes, phenols and acids, antimicrobial effect, antioxidant impact through phenols and aldehydes, retarding fat oxidation, smoke flavor through phenols, carbonyls and others, smoke color formation through carbonyls and aldehydes, surface hardening of sausages or casings through aldehydes, in particular for more rich structure of the casing. The most known undesirable effect of smoking is the risk of residues of benzopyrene in smoke products, which can be carcinogenic if the intake is in high doses over long periods. With normal eating habits, the carcinogenic risk is normally not associated with moderately smoked food such as smoked meat products. Throughout many varying and intricate operations, an ingenious sausage maker, skilled in his task, has to stimulate those desired structural and chemical chains and processes which lead to conversion of raw meat into a final sausage product that his consumers want. The production of a wide variety of sausages is possible through the manipulation of different variables such as meat formulation, processing temperature, types of casings, and particle size. By altering certain processing treatments, changes occur within the product's texture and flavor, moisture content, percentage of yield, and other attributes. The number and variety of sausages are limited only by the manufacturer's imagination and knowledge. In spite of their multiple varieties, sausages may be roughly divided into two general groups: raw sausages and heat processed sausages. According to the methods applied in their manufacture, raw sausages may further be subdivided into two categories: fresh sausages and fermented sausages. There are two principal smoking techniques: cold smoking, hot smoking. This is the traditional way of smoking of meat products and was primarily used for meat preservation. Nowadays, it serves more for flavor and color formation, for example in sausages made from pre-cooked materials such as liver sausage and fillet sausage. The combination of cold smoking and dry ripening can be applied to fermented sausages and salted or cured entire meat pieces. In particular, many raw ham products, apart from providing color and flavor, the cold smoking has an important preservative effect as it prevents the growth of molds on the meat surfaces. The optimal temperature in cold smoking is 15 to 18 degrees centigrade, that is up to 26 degrees centigrade. Cold smoking is a long process which may take several days. It's not applied continuously but in intervals of a few hours per day. Cold smoking is used for fermented meat products, which includes raw cured ham, raw fermented sausage, and pre-cooked cooked sausage, which includes the liver and the blood sausages. Smoke treatment can only be applied if meat, the products are filled in casings permeable to smoke. All natural casings are smoke permeable, as are cellulose or collagen based synthetic casings. Hot smoking is carried out at temperatures of plus 60 to 80 degrees centigrade. Thermal destruction of the wood used for the smoking is normally not sufficient to produce these temperatures in the smoking chamber. Hence, additional heat has to be applied in the smoking chamber. The relatively high temperatures in hot smoking assure a rapid color and flavor development. The treatment period is kept relatively short in order to avoid excessive impact on the smoke, too strong smoke color and flavor. Hot smoking periods vary from not much longer than 10 minutes for sausages with a thin caliber such as frankfurters, and up to 1 hour for sausages with a thick caliber such as bologna and ham sausage and products like bacon and cooked hams. Hot smoking is used for a range of raw cooked sausages, bacon and cooked ham products. Cured meat cuts are made of entire pieces of muscle meat and can be subdivided into two groups, cured raw meat and cured cooked meats. The curing for both groups, which includes cured raw and cured cooked, is in principle similar. The meat pieces are treated with small amounts of nitrite either as dry salt or as salt solution in water. Cured raw meats do not undergo any heat treatment during their manufacture. They undergo a processing period which comprises curing, fermentation and ripening in controlled climatized conditions, which makes the products palatable. The products are consumed raw or uncooked. Cured cooked meats after the curing process of the raw muscle meat always undergo heat treatment to achieve the desired palatability. So students, let's now summarize what we have learnt in this module. Meat processing adds value to products. Value-added meat products display specific flavor, taste, color or texture components which are different from fresh meat. Such treatments do not make products necessarily cheaper. On the contrary, in many cases, they become more expensive than lean meat. But they offer diversity to the meat food sector, providing the combined effect of nutritious food and food with excellent taste. Unlike fresh meat, many processed meat products like a sausage can be made shelf-stable, which means that they can be kept without refrigeration. These shelf-stable meat products can conveniently be stored and transported without refrigeration and can serve as the animal protein supply in areas that have no cold chain provision. New sausage products have offered a revolution in terms of a wide variety of color, size, texture, and appearance, which suit the ready meal market and add further value to sausages. Thank you.
By now, you must have the knowledge of technology of sausages and communited meat products, which has been very well explained by my co-author. Now, in the next module, we'll be knowing the technology of intermediate moisture and dried meat product. And this technology is very important with respect to the shelf life of meat products. Thank you.